All right, so let's see if we can do number 53 and 4.5. They would like us to evaluate the limit, and then we need to learn to read limits, maybe. So, how do you guys say this thing?
What's the limit from?
Okay, so limit
Yeah.
as x
Approaches
tends to infinity.
Tens. I never heard that one. Isn't it approaches?
Sure, yeah.
Oh,
That word
either
can
one,
be-
either one. Okay.
Yeah, so I'm going to say this word, x tending to infinity, x going to, x approaching. Like, I'm going to say lots of stuff here.
Okay.
So limit as x tends to infinity of yeah, and then read that thing. So e to the minus 3 half. Cool? So limits that word. This bit is the
Nice.
x tending to infinity, and then the of is just, that's the thing you're doing this to. Notice this thing acts a little bit like a function. You guys see that? This is kind of a meta thing, right? This is like a little bit like a function, and what it takes in is a little bit like is actually a function. You guys see that? So this is kind of a function that acts on functions. It's not really actually a function, it's a mapping. Cool? All right, so can I execute this? In other words, what the hell is this thing asking me to do now that I've parsed it out into words? Okay.
It's been a while.
So let's parse this into less complicated words. Yo dog,
Oh god. This makes it hard.
Supposed to be spelled with an A and a W.
what happened? Oh yeah, I probably spelled dog wrong. What happens as x gets, what's tending to infinity mean?
They supposed bigger.
Big. Biggish. Bordering on huge.
I'd say bordering on
It's
infinite.
towards bigliness.
Bigly.
What happens as x gets bigly? So basically I'm just wondering, what does this function do as I run towards the right end of the graph?
Y gets bigger.
You guys see that? So does y gets bigger?
Oh, no, negative.
What's this thing look like? So what's e to the minus 3x look like?
That'd be it.
Yeah, some kind of exponentially decay dealy-hoo. Right? Okay. So what happens as x gets big? As x gets big, y gets small, right? The output gets little. Okay. This goes to 0. You guys see that? This is really asking, as you run to the right end, what does this thing tail off to? Cool. That's a positive infinity. If I had a negative infinity here, what would I be asking?
Infinity. Yeah.
Yeah.
Otherwise, fine. Yeah.
You guys see that? If I ask towards negative infinity, I'd be saying what happens as x gets negative bigly, right? And then we'd be running left. And of course, the outputs just keep going up and up and up. Cool? So we'd write positive infinity for that. You guys don't have a very precise definition of what this thing means, right? So you're going to have to draw a picture and kind of guess at it. That's okay. This is the only new content in calculus. So I'm not going to give it to you today. But you can look at a picture and kind of chase it around.
Sweet.
Cool. It is worth noting that this thing doesn't necessarily have to have an answer. You guys give me a function that doesn't have a limit as x goes to positive infinity?
Is it when it just like stops?
Yeah, y equals 2.
Oh yeah, okay, so if it stops, like that would be weird.
Yeah.
Like if your function just looked like this.
Yeah.
Yeah, that would be a little bit strange.
Because you couldn't go to infinity. It would just.
Yeah, because those inputs don't even make sense.
Yeah.
That would be reasonable. Another thing I could do is I could do some kind of oscillating behavior, right? Because like, where does it tend to?
Okay.
Well, it doesn't really tend anywhere. It just wobbles up and down, right?
Would you put an average in that case of the maximum?
No, we just say it doesn't work.
Okay.
So these would be two examples of the limit x tending to infinity of, I don't know, we'll call this thing f of x, does not exist. Cool? Same thing here. Wobbles too much. If it wobbles less and less as it goes along, then maybe it could come to something.
Like 0.
Yeah. You guys cool with that? Springs do this, right? Like this is just asking what's going to happen in the end. This is a frictionless spring in a vacuum.